In this first section of Chapter 11, we're going to talk about how to graph square root functions using function transformations. First, I wanted to discuss a little bit what radical functions are and what they look like, and then specifically what square root functions look like. So radical functions contain radical expression with the independent variable, in our case it's x, in the radicand, which means underneath the square root or cube root or fifth root. So these are some examples of radical functions. We have square root here, cube root, fifth root, and fourth root. And if you notice, the x, which is the independent variable, is always inside the radicand. So square root functions contain specifically square roots. So there is no cube root or fifth root. They're all square root functions, and they also have their independent variable in the radicand, which is the expression inside the square root. Okay, so then we're going to go to the next slide, and we're going to take a look at what the most basic square root function looks like, and we call it a parent function because every other square root function can be graphed using the parent function that we have here. So what we're going to do first is we're going to create a small table to get some points. We can't have a negative inside the square root. So if you try to plug in a negative underneath the square root, you're going to get an undefined answer, so we can't actually graph it. The smallest x value that we can have here is going to be 0, and then we're going to use 1. And to make our numbers nicer, we're actually going to keep using perfect squares, because when we take a square root of 0, we get 0. When we take a square root of 1, we get 1. When we take a square root of 4, we get a nice integer, which is 2. And when we take a square root of 9, we get 3. And the reason why we skipped some of the numbers between 1 and 4 and 4, 9 is to have these nice y values. So then we have 4 points that we can plot: 0, 0, 1, 1, and 4, 2, and 9, 3. And that's what our parent graph is going to look like. And it's actually half of a sideways parabola. So if you have this on your paper and you turn it sideways, you'll notice that this is a left side of a parabola, where this would be the vertex. Now, a couple of things we need to notice. We need to talk about domain and range here. Our domain is going to be all the x values that we are using. And if you notice, our graph does not go to the left of 0. It does have 0 as an x value, so it's going to be all x values greater than or equal to 0. Our range is going to be about the y values, and the lowest y value, so here's our y-axis that we can get to, is also going to be 0. We can't go any lower than that, but we can go above that. So our range is going to be greater than or equal to 0. So we no longer have a domain of all real numbers. We actually have to think about our domain. So in class we worked through an activity where we discovered some of the transformations, and I wanted to review some of them. So the first type of transformations we looked at in class were horizontal and vertical shifts, and they resulted from adding or subtracting numbers either inside square roots or outside. When we had number added or subtracted inside the square root, this is our horizontal translation. So these are horizontal translations on the left, and these are a little tricky. If you're subtracted 3, we actually moved right 3. And if we added a 4, we actually moved left 4. Now on the right side, we're now, and hopefully you can see the difference, now the square root of x is the only radical part, and then we're subtracting 1 after the x is being square rooted. So now we have a vertical translation. So we're going to be moving up and down. And this one is more straightforward. So if you're subtracting 1, that means you're subtracting 1 from all of the y values, so you're going to move down 1. And then here we're adding 5 to all of our previous y values, so we're going to move up 5. Okay, so then we had another type of transformation. We had vertical stretches and shrinks. So vertical stretch and shrink. And a quick reminder, these were stretches and shrinks away from the x-axis. And also we had reflections when we had a negative sign in the front. So we have a couple transformations here. The negative is going to make us reflect over the x-axis. And then the 3 in the front makes us take all of the y values and multiply them all by 3. So that's going to result in a vertical stretch by 3. Over here we don't have a negative, so we just have to worry about stretching or shrinking. And now we're going to take all of our y values and multiply them by half, so they're going to get smaller. So this is a vertical shrink of 1/2. The last two examples have a lot of several transformations all in one, so we're going to take a look at how to list them. And what we're going to do is in order to have the right order, we're going to follow the order of operations. So all of our multiplication is going to be addressed first. So here we're multiplying by 4. So this is going to be a vertical stretch of 4. Then we're going to worry about our subtractions. It doesn't matter which order you do it in. I'm going to do the inside first. So because it's inside the radical, we are shifting horizontally, and this is going to be right 4. And I can't spell. So this is going to be a horizontal translation, right 4. And then we have our -4 here, which would be vertical because it's on the outside. So vertical translation down 4. And it's very important that when you start graphing, you actually follow this order of operations or translations to have the correct graph. Our last example, we have 4 things going on here. And when I say 4 things, I'm talking about when compared to the very basic parent graph. So if you were to take a y equals square root of x, what's happening to this? And we have a negative here. So I'm going to address that first. So the negative is going to make us reflect over x-axis. Then we have the 3. And again, remember, we're doing all the multiplication stuff first. It's going to be a vertical stretch by 3. And then I have this +4, which is inside the radical, so this is a horizontal translation, left 4. And then I have a vertical translation up 2. So we have a vertical translation up 2. And this is really, these 2 slides are the key to the whole lesson. Okay, so now we're going to apply all what we know about transformations to graphing new functions. So what I always encourage you to do is graph our parent function, which is just square root of x. And if you forget, you can always plug in some values. So this is going to be our parent graph. And then what we're going to do is we're going to think about how the graph we have is going to be transformed from the parent function. So the only thing we have here is this 3, and it's multiplied on the outside by 3, which means that this is a vertical stretch of 3. What this means is that all of our points are now going to be 3 times as far away from the x-axis, which is right here. So let's start with this point here. It used to be at 0, and if I multiply 0 by 3, I'm still going to be at 0. This point right here is 1 unit away from the x-axis. So now I'm going to be 3 times as far, so now I'm going to be 3 units away from the x-axis. This point right here is 2 units away. So if I multiply that by 3, now I'm going to be 6 units away. And this point is 3 units away from the x-axis, so now I'm going to be 3 times as far, which is going to take me to 9. So this is what it's going to look like. and this right here is not correct because we want to make sure it's a function. So this is what it's going to look like. Now we're also asked to identify domain and range. So our domain is going to be x is greater than or equal to 0 because we're using all the x values to the right of 0, including 0. And our range is going to be y is greater than or equal to 0. And when they ask you to compare the graph to the graph of y equals square root of x, this is all we're looking for, the vertical stretch of 3. Here's another example, and we have y equals negative 1/2 square root of x. And there's two things going on here. We have a negative and we have the 1/2. The negative is going to make us reflect over the x-axis, and then the 1/2 is going to make us have a vertical shrink of 1/2, and you can do them together. So first what I'm going to do is I'm going to graph my parent function so I can use my points. And I'm just going to fix this real quick because I missed my point here. Okay. So I'm going to do both of them together. So I'm going to be reflected over so we're going to have a graph reflected over the x-axis is going to go this way, and we're also going to shrink it by half. So 0 stays at 0. This point used to be 1 away, so now it's going to go in the opposite direction, and it's also going to be half as close. Instead of 1, it's going to be half away. This right here is twice away from the x-axis. We're going to reflect it, and then we're going to shrink it by half. This right here is 3 units away. I'm going to reflect it, which is going to take me here, but then I'm only going to be half as far from the x-axis. So this is what it's going to look like. So reflection is going to make it go down, and then the shrink is going to make it a little narrower. It's going to be closer to the x-axis. Our domain is going to be x is greater than or equal to 0. And our range is going to be a little different now because our range is going to be y is less than or equal to 0, because now we're using all the y values that are actually smaller than 0 instead of the greater than 0. Okay, so now we're going to take a look at the vertical translations. So we have our graph square root of x plus 2. Plus 2 is on the outside, so we're going to be moving up and down, and this will be a vertical translation up 2. So we're going to take our parent graph and we're going to graph it. And then we're going to translate all our points up 2. So all we have to do is take this point, move it up 2. We're going to take this point, move it up 2. Take this point, move it up 2 blocks, take this point, move it up 2, and that's all we have to do. So then our new graph is going to look like this, and we're going to answer the domain or range question. So our domain is going to be all the x values greater than or equal to 0. Our range is now going to be all the y values greater than or equal to 2 because we don't have anything below 2. So y is going to be greater than or equal to 2.